Oh, yeah, I'm not going to do that. Well, actually, I'll probably turn the lights off, but I'm going to leave the projector on. I don't want to be in complete darkness, you know. So I'll turn the lights off, but I'll leave the projector on so we have some light. That way I'm doing what I'm supposed to be doing. And it says don't use your phones. Just don't. You can use, you know, you could check your email or whatever. You just don't talk on your phones. Okay. Anyway, let's go. So until we have a lockdown. So we're going to do section 4 and hopefully section 5 today. We will have one more test. Oh, I do have the test to hand out. So let me do that. So for you guys online, if you want your test, go and come and get it. I already posted the grades, which you may already know. So the average was about what it normally is.
I did an MTH over the summer, and I loved it. I know it's really crazy, but I love like doing it every day. Like, I don't know why that's like so true. Like, I got 100 on all of my. And this is the last question. I watched the video like 3 times on how to do it. And I still, like, when I got into the test, I was like, oh my gosh, I completely forgot everything I studied.
Okay. Did I give you yours yet? No. Okay. Oh, there you go. There's yours. So the average is around an 80, which is what we're on the other tests. So I did curve it. Okay, so we're going to talk about greatest common factor and least common multiple. So it's these are important for things like fractions, finding common denominators, things like that. So the definition of the greatest common factor, so you have multiple numbers. You can have 2 numbers, you can have 3 numbers, you know, you can have as many numbers as you want. It's the greatest common factor of a group of natural numbers is the largest natural number that is a factor of all the numbers in the group. So one thing you could do is list all the factors and then find the biggest one, but that would be more work than we need to do. So here's an example. 36 and 54, the greatest common factor is 18 because 18 is a factor of 36 and 18 is a factor of 54, and that's the largest factor. So that's why it's called the greatest common factor. Whereas something like 7 and 16, they don't have any, you know, you can't, the factors of 7 are 1 and 7, and the factors for 16 don't include 7. So the greatest common factor for these 2 numbers is just 1. It's also sometimes called the greatest common divisor. We'll just call it the greatest common factor. But what you can do is you can use prime factorization to come up with the answer without having to list all the factors. And there's 2 ways of doing it, and they give you the same answer. The first method is you write the prime factorization for each number, and then you choose all primes that are common to the factorizations, and you use the prime number that's in the prime factorization that has the least exponent. So the least exponent, if you had something squared or something in the first power, you'd choose the first power. If you had something cubed or something squared, you'd choose squared because that would be the least. And then you take those numbers from step 2 and you multiply them together, and that gives you the greatest common factor. So I mean, you can write that down for your, I mean, you can write that down in your cheat sheet. So I'm not going to, what we're going to do is we're just going to go through some problems using this steps, show you the steps. So the first step in all of these is to do the prime factorization. So remember, prime factorization is you take the number and you divide by 2 until you end up with an even number, an odd number. So 400 divided by 2 is 200. That's still even, so I divide by 2 again. I get 100. I divide by 2 again, I get 50, and I divide by 2 again, and I get 25. So I've got to divide by, if I divide 400 by 8, 2 times 2, well, actually it's more than 8, it's 16. If I divided 400 by 16, I'd get 25. But I do it in, I don't do just 16 at one time. I always use the smallest prime number I can use until I can't use it anymore. So when I get to an odd number, then I stop as far as the 2's are concerned. And then I say, okay, what's the next prime number that I can divide this by? Well, I can't divide it by 3 because 2 plus 5 is 7, which is not divisible by 3. So I go to the next prime number, which is 5. And I say, okay, 25 divided by 5 is 5. So that's the tree. And then my prime factorization is saying that 400 is equal to, well, it's 2, which is the smallest prime number, raised to the 4th power, because there are 4 2's, times 5, which is the other prime number, raised to the 2nd power. So that's my prime factorization in terms of the prime numbers and their exponents. And you do the same thing for the other number. So we divide 110 by 2, and we get 55. So that's, we only can do it one time. So then we say, okay, can we divide that by 3? The answer is no, because 5 plus 5 is 10, which is not divisible by 3. So we try 5, which works, because it ends with a 5. 55 divided by 5 is 11, and that's a prime number, so we're done. So our prime factorization for this number is 2 times 5 times 11. So that's step A. Step B says choose all primes common to all factorizations. So we look at the factorizations and see which ones or which prime numbers are in both factorizations. So the 2 and the 5 are in both factorizations, but 11 is only in this one, so we don't list it. And then we look at the exponents. And I don't write 1, but there is 1 there. So you take the smaller of the 2. So I do 2 to the 1st power, because that's the smallest. And as far as 5 is concerned, I have 2 and I have 1, so the smallest there is 1. So that's choose all primes common to all factorizations with each prime raised to the least exponent. And then it says form the product, which just means multiply them together, and you get 10. So therefore, the greatest common factor of 400 and 110 is 10. If I divide 400 by 10, I'll get 40, and if I divide 110 by 10, I'll get 11. So anyway, that's one method for doing it. So let's actually, we'll save, let's do another one. So I'm going to actually do another example for you. So I'm going to put a page inside here. Let's do these two numbers using the same technique instead of going to a new technique. So we have to do the prime factorization for each one of these numbers. So we just divide by 2 until we get to an odd number. Okay, here we go. Well, I thought it was happening. Okay, so we're having a lockdown drill, so I'm going to stop the recording for right now. Okay, back to greatest common factor. So we're continuing on. This is divisible by not 3. You can go. Yeah, I don't know either, but I think it's okay. I think as long as we have been released, we're okay. Okay, so 135 divided by 3 is 45. And that's also divisible by 3. And that's 15. And that's also divisible by 3, which is 5. So my prime factorization for 540 is 2 to the second power times 3 to the third power times 5. And we do the prime factorization of 1200. We get that far with even numbers, or by numbers, the 2's. And then this is divisible by 3, because 7 plus 5 is 12, which is divisible by 3. So we get 25. 25 is divisible by 5. So the prime factorization for 1200 is 2 to the fourth power times 3 times 5 squared. So the greatest common factor, you take each number that's common in the factorizations. So 2 is a common number, 3 is a common prime, and 5 is a common prime. And then you go back and you look at the minimum of the exponents. So this is to the second power, this is the fourth power, so we use the smaller of the two. This is cubed, this is the first power, so we do it the first power. And here we have it to the first power and squared, so we do it to the first power. So that's 4 times 3 times 5, which is 60. So the greatest common factor of 540 and 1200 is 60. Okay, so that's one technique. And I ask you to know how to do both techniques, even though you really only need one to be able to solve these problems. So I'm going to use these same two numbers because we already know what the answer is. The second technique is you do the prime factorization, and actually this is the same technique. Okay. I forgot, I didn't realize that was the case. So let me just delete this page because I just repeated something. Okay, this is the second method. And what we'll do is we'll save these for later. We'll do the ones we just did. We'll do one that we've already done so we can confirm that we have the same answer either way. Oh, it's all grouped together. Okay, anyway, let's put this on one page. So it says, that's the same one again. Oh, okay. Yeah, we're still not getting to the new one. This is how you do it when you have three numbers. Okay, so we've done it with two numbers, so let's do it with three numbers. So you do the same thing. You do the prime factorization for each number, but in this case you do it 3 times because you've got 3 numbers. So I'm just going to go ahead and do these, and you can, if you have questions about how I get these, let me know. Wait a second. Here. Okay, so those are the prime factorizations. I did that right. 78, 13. Okay, so if I write them out, 52 is equal to 2 squared times 13. 39 is equal to 3 times 13, and 78 is equal to 2 times 3 times 13. So again, my greatest common factor, I look for terms that are in all 3 of them, not just in 2 of them. Well, 2 is in 2 of them, but not the third one, so we don't write that down. 3 is in 2 of them, but not the third one, so we don't write that down either. And the only one we have that's common to all 3 factorizations is 13, and they're all to the first power. So it turns out the greatest common factor of those 3 numbers is 13. Okay. Then I'm going to go steal this one I did earlier. This one right here. What was it? 540 and 1200. So the second method is called dividing by prime factors method. So it says you write the numbers in a row. In this case, I just have two numbers. And you draw like you normally do with prime factorization, but you draw it for both numbers. And it says divide each of the numbers by a common prime factor. So since they're both even, I can divide both of them by 2. So 540 divided by 2 is 270. 1200 divided by 2 is 600. Okay, then you look at it again and ask, is there a prime number that I can divide both of them by? And they're both even still, so I can divide both by 2. So 270 divided by 2 is 135, and 600 divided by 2 is 300. So I can't divide by 2 again because they're both not even. So then I have to think about what's the next larger prime number, which is 3. So can I divide this by 3 and this by 3? That one's obviously you can divide by 3 because it's 300. This one, you'd add the numbers together. 1 plus 3 is 4. 4 plus 5 is 9. So yes, you can. So we can divide both of them by 3. And 135 divided by 3 is 45. And 300 divided by 3 is 100. Okay, and then you ask, can I divide that by 3 again? Well, this one I could, but this one I can't. Because these add up to 9, which is divisible by 3, but this adds up to 1, which is not divisible by 3. So then you go to the next prime number, which is 5. And can I divide these both by 5? And the answer is yes, because the end in 5 or 0. So I'm going to do that. So 45 divided by 5 is 9, and 100 divided by 5 is 20. Okay, now can I divide both of those by 5 again? No. So at this point I can't divide either of them by a common factor because the only factor of this is 3 or 9, and I can't divide this by 3 or 9. So once you get to a point where you can't divide both of them by the same prime number, you take the 4 numbers here that you've already used and you multiply those together. So my greatest common factor is 2 times 2 times 3 times 5, which is 60. And if I go back, so I got 60 from a greatest common factor, and you see I got 60 using the other method. So you get the same answer. This is a little more compact because I didn't have to do 2 prime factorizations. I didn't have to factor stuff that I didn't actually need to use. So let's do it again, but let's use it for 3. So we're going to take these numbers over here, and we'll write them out again. 12, 18, 36. We'll draw one big long bracket. And we start again at 2. And we say, are they all even? And the answer is yes. So I can divide everyone by 2. And then I ask, can I divide by 2 again? The answer is no, because this is odd, so this is not divisible by 2. So then I go to the next larger prime number, which is 3. And you can divide each one of these by 3. So 6 divided by 3 is 2, 9 divided by 3 is 3, and 18 divided by 3 is 6. Okay, and then you ask the question, can I divide, 2's already been used, 3, I can't divide 2 by 3, so I'm done. You can't, there's no common factor, so I just take these 2 numbers. And so the greatest common factor is just 2 times 3, which is 6. The other way, I would have used prime factorization for all 3 of these numbers, looked for common numbers in the prime factorizations and used the minimum value. Some people don't pay attention and they just list all the factors and then they pick out the biggest one. Well, that doesn't work. Okay, so don't just brute force the whole thing. That's not going. I'm not going to give you credit for that. You've got to use one of these. You got to use the appropriate method that I tell you to use. But somebody invariably forgets to do this, and they're like, "Oh yeah, I know what it is," but that's not the point. The point is using prime factorization to make the process easier. Okay, why don't you guys try this? So use this technique over here for these two numbers. And for you guys online, if you can, once you get an answer, write in the answer and raise your hand. I think James came in after did I hand your test back, James? I don't think so. You came in after I handed them back. Oh, you were the bookstore guy? Yeah. What was his opinion? So you may not have known you may not know this, but Donald Trump's son-in-law, his father was prosecuted by Chris Christie, who is the governor of New Jersey and was the head of the transition team for Trump. Yeah, so Christie has been dethroned because, well, the speculation is that Donald Trump's son-in-law basically said, you know, this guy put my father in jail, and so I don't want to have anything to do with him around. And I think they didn't want to do that during the campaign because they wanted to use Chris Christie while they could. But as soon as the results were known, then, you know, and then so a lot of the other guys that he appointed also decided to leave the transition effort. So they're kind of, but they're like 4,000 jobs they have to fill 4,000 jobs before, well, maybe not before inauguration, but ultimately these are all the political appointments that you had, you know, dog catcher. So I mean, it's not that far down, but it's surprising the number of political appointments that there are. You don't think so? That's what you hope. That's what you hope for. That somebody competent. Yeah, right. Yeah, either make it work or get rid of the guy, right? So I guess we ought to make it work. Okay, anybody got any answers yet here? Oh, you got 10? Yeah, that sounds reasonable. Wait, we'll see if anybody online gets an answer here, see if anybody's paying attention. I guess the question is 41 a prime number? It is, yeah. So 10 is the answer. So for you guys online, the answer is 10. So enter 10. So I know you're paying attention. So anyway, what you would do is you would start out with 2 because they're both even. So if you divide both of them by 2, you get 205 and 180. So they're not even now. So you have to go to an odd number, or to the next larger prime number. So that would be 3. This one is divisible by 3. And the question is, did I ever push the talk button, or are they all? Yeah, I did. Okay, I just make sure they're listening to me. So this one's divisible by 3, but this one is not. So you go to the next prime number, which is 5, and they are both divisible by 5. So 205 divided by 5 is 41, and 180 divided by 5 is 36. Yep. So we look at this, and because 41 is a prime number, obviously we can't go any further. So that leaves us with these two numbers. So the greatest common factor is equal to 2 times 5, which is 10. But when you asked me, is 10 right, what I did is I divided both by 10, and I saw that one of them was a prime number. So I knew that was the right answer. Okay, so those are the two methods for finding greatest common factor. You'll get homework practice at that. There's also this interesting way of doing it, which it's kind of interesting it actually works. And I do include this on the test. So some people find it kind of difficult to follow. This is probably the part that people have the most trouble with, but I'm going to try to explain it even so. And you can read this, but the best way to do it is to explain it. I'm going to read it, but I'm going to do a couple of examples. So it says to find the greatest common factor of two unequal numbers, divide the larger by the smaller. Note the remainder and divide the previous divisor by this remainder. Continue the process until a remainder of 0 is obtained. The greatest common factor is the last positive remainder obtained. Okay, that's clear as mud. So let's demonstrate it. And so let me actually delete all that stuff so we can know what happened there. That happened yesterday too. Maybe I'm pushing the wrong button. There we go. Okay, so let's read it and see what they're saying. It says, note where it is, divide the larger by the smaller. This is the larger, divided by the smaller. So when you divide 60 by 35, you get 1. 1 times 35 is 35. You subtract that, and when you subtract that, you get 25. Well, the remainder is not 0, so we're not done. Then it says, note the remainder. So that's my remainder. Divide the previous divisor by this remainder. So this is the previous divisor. So you take 35 and you divide by the remainder. So 35 divided by 25, again, you can do that one time. So 1 times 25 is 25. And you subtract, and you get 10. So that's my remainder. So what it says now, it's not 0, so we keep doing it. So you've got these, basically you have 3 numbers, this one, this one, this one, but you compare these two. So you take the previous divisor and divide by the remainder. It looks like it's not going anywhere, but it'll work out. Have faith. So you divide by, you can multiply 10 times 2 to get 20. And let me erase this stuff down here. And when you subtract that, you get 5, which is still not 0. So you're like, oh, I'm giving up on this, but don't give up yet. So you take 10, which is a larger number, divide by the remainder, which is a smaller number. Your remainder is always going to be smaller than this number. It wouldn't be a remainder otherwise. So 5 divided by 10, you can do that 2 times. So we will finally get a 0 remainder. 5 times 2 is 10. Subtract that, you get 0. So it says, continue the process until a remainder of 0 is obtained. The greatest common factor is the last positive remainder obtained. So that's the last positive remainder obtained. So that means the greatest common factor is 5, equals 5. And if we go back to our numbers here, 35 and 60, if you take 35 divided by the greatest common factor and do the other one, you'll end up with 7 and 12. And you can see the resulting numbers, there's no common factor between those two. That's kind of a way of checking to make sure it actually works, is to divide the original numbers by the greatest common factor, and the results should be integers, but they should not have a common factor. And obviously 7 and 12 don't have a common factor. Okay, let's do one more, and then we'll get some practice for homework. So here's two numbers. So you take the larger number, divide by the smaller number. How many times will 24 go into 108? Probably 4 with some remainder. So if we take 24 times 4, we'll get 96. So you subtract 96 from 108, and you'll get 12, which is not 0. So we're not done. The next thing you do is you take this number, divide this number by that number. So you'll take 24 divided by 12. That goes twice. You multiply 12 times 2, you get 24. You subtract them, you get a 0 remainder. So the greatest common factor is the previous remainder, which is 12. So what we can say is that the greatest common factor equals 12. And again, we can check that out by taking the original two numbers and dividing by 12. And you'll get 2 here, and 108 divided by 12 is 9. So if you look at these two numbers, they don't have a common factor because you can't divide 9 by 2. So that confirms that that's the correct answer. So that's how it works. You know, is it any better than any of the ones? No. Why do we do it? Because it's kind of one of those interesting math things that actually work. How did somebody figure this out in the first place? I have no idea. But it's kind of a neat math thing. Okay, next thing, least common multiple. So, you know, if you look at multiples of a number, it's the number times 1, times 2, times 3, times 4, times 5, times 6, times 7. So, and then same down here, times 1, times 2, times 3, times 4, times 5, times 6, times 7. And then what you do is you look for the same number the first time you see the same number in both multiples. So I see 30 is a multiple of 5, 15, and 30 is a multiple of 10. So this is what we call the least common multiple. There's other common multiples. 60 is a common multiple. 90 will be a common multiple, but 30 is the smallest of the common multiples. So it's called the least common multiple. So how do you do that? Well, there's two techniques. We don't have a third technique. We just have two techniques. So it's basically the same two types of techniques, except use a different rule to figure out what the answer is. So you still do a prime factorization of each number, but the new rule is you choose primes that belong not to all factorizations, but any factorization. And you choose the greatest exponent instead of the least exponent. So it's kind of exactly opposite. And then you multiply the numbers together and you get the least common multiple. So what we'll do is we'll use these rules to find the least common multiple of these two numbers. So let's follow the rules. So it says do a prime factorization. So again, I'm going to do this. I'm just going to do it. If you have any questions of how I do it, ask me. So those are the two prime factorizations. And again, you can always check your answer by just multiplying this thing out. So 2 squared is 4. 4 times 3 is 12. 2 times 2 is 4. Times 2 is 8. Times 2 is 16. Times 2 is 32. So that's true. So the rule now says So the least common multiple, you take prime numbers that are in any of the two factorizations. So 2 is in both of them, but that's not, it just has to be in one of them. So we have 2, and we also have 3. 3 is only in one of them, but that's all that matters. We don't have put 5 because 5 is not in there. And then you choose the largest exponent. So here, instead of choosing the smaller one, I'm going to choose the larger one. And here, there's only one of them, so it's to the first power. So that ultimately ends up being 32 times 3, which is 96. So that is the least common multiple of these two. And if I did it the brute force method, which I hope you wouldn't do, but I'm going to just to show you that it does actually work. These are multiples of 12. And these are multiples of 32. So you can see the first common multiple we have is 96, and that's the answer. So that's what it's doing. It's instead of multiplying out, and in this case it probably took about the same amount of time, but if you had a very big common multiple, you'd be spending a heck of a lot of time multiplying all that stuff out. So let me give you one to work on here. So we're going to do 90 and 50. So here's procedure. So you can do the prime factorizations of 90 and 50. Once you get the prime factorizations, then you'll pick prime numbers that are in either of the two factorizations, and you'll choose the highest exponent. Did anybody ever answer the question earlier? You guys, nobody gave me an answer. So here's your warning. If you don't put any answer in this time, you're not considered to be present at this point. So don't. Your warning. Huh? Yes, I know. That's me, Mr. Stern. Doesn't have to be right. You just have to give me an answer. So what'd you get, Jackson? So you say you got 90? Yeah, but yes, the 90 is not a multiple of 50. So you know that's not right. Okay. Well, we will in a second. That's the second method. This is the first method. So this is kind of like equivalent to the first method that we did for greatest common factor. So what you would do is, you see I've got 2, I've got the prime number 2, I've got the prime number 3, and I've got the prime number 5. So those are in either one of them. And then I pick the largest exponent. Well, these are both to the first power, so that's fine. The largest exponent here is 2, because it's only one of them that has it. And the 5, the largest exponent, is 2. So I get 2, and again, they don't have to be in both of them, they just have to be in one of them. And then you pick the largest one. So that'll be 2 times 9 times 25. And 2 times 9 times 25 is 2 times 9 times 25 is 450. So 450 is the least common multiple. So you guys online, if you can write that answer in your chat thing, so I know you're paying attention. I'm afraid to look because I'm not. Oh, good. Timber's at least paying attention. Okay. We'll come back and look at that later. So the same thing. So now we're going to do 3 of them. So you use the same procedure for 3 of them. So you do the prime factorization of all 3. So we'll get 2, 3, and 5. So 2 times 3 times 5 is 30. And then we do 40. So you divide by 2 until you get an odd number, which is when you finished. So that's that one. And then you do the same thing for 70. So 70 divided by 2 is 35. This is not divisible by 3 because 3 plus 5 is 8, which is not divisible. So you divide by 3, which you can't do either. I just said I couldn't do 3, and then I did it. That was stupid. So then you can divide by 5, and you get that. So the prime factorization of these 3 numbers, 30 is 2 times 3 times 5. 40 is equal to 2 cubed times 5. And 70 is equal to 2 times 5 times 7. So those are the prime factorizations. And so the least common multiple, we look at what numbers are in these factorizations. Well, 2 is used, and again, it doesn't have to be in every one, it just has to be at least one of them. So 2 is used, 3 is used, 5 is used. So I can, I've finished that one. Let's see if there's anything else besides 2, 3s, and 5s. Well, 7. Okay, so those are the prime numbers that I used. And then you go back and look for the highest power. Well, the only one that's raised to a power is 2, so I'm going to cube that. But all the other ones are to the first power. Yes? No. For least common multiple, you just have to make sure that these numbers are at least in one of the 3. And then once you've kind of done an inventory of prime numbers that are used, this is only used once, but it's been used, so you stick it in there. Once you've got all that kind of taken care of, then you go back and look to see the exponents. And if there were any of these others that were raised to a power, then I would use that power, but they're all just raised to the first powers. Whereas this one's cubed, so I use the highest exponent. The only one that has an exponent different than 1 is this one. So that gives you 8 times 3 times 5 times 7, and you multiply those together. 8 times 3 times 5 times 7 is 840. So the least common multiple of these numbers is 840. So I think that's all that I'm doing with the prime factors method. The other method is dividing by prime factors method, which is like we did with greatest common multiple. We're going to do all 3 at one time, but what you're going to do here is you're going to not just multiply. Well, if you go back to the greatest common factor using the least common multiple, where Where did we do it here? Let me go back to greatest common factor. You know what we did here is we took these numbers. Well, what we're going to do is take these numbers and multiply them by what's left over here. That's the difference in the method when you're doing least common multiple. But it's the same basic procedure. So what we're going to do is we're going to list, it's the same one we just did. So you list 30, 40, and 70. And we look for a number, a prime number, that you can divide all three of them by. Well, actually, it's a little more complicated than that, to be honest. Let me show you how this works. So that's why I have a couple of examples, because this is probably the hardest one. So you divide, if you can divide them all by one number, that's great. And I can because they're all even. So you do the division. And what you see is I can't divide all of these by 2. I can divide them all by 5, so I can, as long as you can divide by the same factor, that's great. So you keep doing that. So 15 divided by 5 is 3, and 20 divided by 5 is 4, and 35 divided by 5 is 7. And in this case, you can't divide any of them by any common factor. Okay, these are prime numbers, and this one's not a multiple. So what you do in this case is you just multiply all these numbers together, these 5 numbers together. So my least common multiple is 2 times 3, well, 2 times 5, let me erase that. 2 times 5 times 3 times 4 times 7. And I should get the same number if I did it right. 2 times 5 times 4 times 2 times 5 times 3 times 4 times 7, and I get 840. So it does work. So that's the easy case where you can divide them all by the same prime numbers, and then you end up with without any common factor, and you just do the whole thing instead of just this part. You can see if I multiply these two together, I'd get 10, which would be the greatest common factor between these three. But I'm finding the least common multiple, so I'm doing that. Okay, now let's do these 2 numbers instead of 3 numbers. So again, can I divide by 2? Can I divide by 2? No. Can I divide by 3? Yes. So 45 divided by 3 is 15. And 75 divided by 3 is 25. Can I divide those both by 3? No, because this is not divisible by 3, so I go to the next larger prime number, which is 5. 15 divided by 3 is by 5 is 3. 25 divided by 5 is 5. Can I divide these by a common term? The answer is no. So my least common multiple is going to be these numbers multiplied together. So the least common multiple is 3 times 5 times 3 times 5, which is probably 225, I think, but let me try. 3 times 5 times 3 times 5, 225. And you can always check it out by dividing this by those 2 numbers. If you take 225 divided by 45, you'll get 5. And if you take 225 divided by 75, you'll get 3. Okay, so these are the easy ones. The next one I think is a little harder. So you write these 3 numbers out. And they're all even, so I'm going to divide every one by 2. Now, I can't divide them all by 2 because this one's odd. I could divide both of these by 3, but I can't divide that by 3. So how do I handle the case where not everything is divisible by the same prime number? I don't just give up and just multiply these numbers together. So the key thing is if you have two numbers you can divide by the same common factor, you do. So I'm going to do 2 because I have two even numbers here. So what you do is you divide the two even numbers by 2. But this number that you can't divide by 2, you just bring it down. And then you do the same question. Are any of these three numbers divisible by the same number? And the answer is yes. This is divisible by 3, and this is divisible by 3. So you write 3 there, and you do the divide. You divide out what you can, and you bring down what you can't. So 3 divided by 3 is 1. 21 divided by 3 is 7. And then this one you just bring down without doing anything. And then you ask the question again, can I divide all these by a common factor other than 1? And the answer is no. So once you get to the question, answer, I can't divide any of them by the same number, then I'm done. So my least common multiple is 2 times 2 times 3 times 5 times 7. 2 times 2 times 3 times 5 times 7 is 420. So my least common multiple is 420. And again, if I take the 420 and I divide that by these three numbers, you'll see why that makes sense. So let's do another one that's kind of complicated like that. Actually, let me make one up because that's not. So let's pick a couple of other numbers. So let's try 15, 25. Actually, let's pick 90, and I'll try 120. So we want to find the least common multiple of those three numbers. So hopefully I picked these right. I mean, there's nothing wrong. I just want to see if I can generate something that works. So you notice that they're not all even, so I can't divide by 2. They are all divisible by 3, so I'm going to go do that. So 15 divided by 3 is 5. 90 divided by 3 is 30. And 120 divided by 3 is 40. So at this point, I can't divide them by 3 anymore. I can divide this one by 3, but I can't divide these two by 3. So you need at least 2. So the next thing I do is I'd say, okay, I'm going to try 5. And you can divide each one by 5. So 5 divided by 5 is 1. 30 divided by 5 is 6. And 40 divided by 5 is 8. So what I can do is, this I can't, it's as low as I can go. So I look to see if the two remaining numbers can be divisible by a common factor. And the answer is yes, it's 2. So I'm going to divide, I don't divide this by 2 because I can't divide it by 2. But I can divide 6 by 2, which is, so I'm going to bring this one down. And 6 divided by 2 is 3. And 8 divided by 2 is 4. Now, there's no common term that I can divide both these by. I can't divide it by 2 because you can't divide 3 by 2. So I'm done at this particular point. So I'm going to multiply all these numbers together. So my least common multiple is 3 times 5 times 2 times 1 times 3 times 4. 3 times 5 times 2 times 1 times 3 times 4 is 360. And you can see this, if you look at, if you take 360 and divide by 12, you'll get 30. So this 360 is the 30th. It's 12. It's 15, not 12. It's 360 divided by 15. It's the 360 is the 24th multiple of this. If you take 360 divided by 90, you get 4. So 360 is the 4th multiple of this, and 360 divided by 120 is 3. So 360 is the 3rd multiple of 120. Okay, we'll do one more. This is the one people find the most difficult. So let me see if I can figure out something to do here. 21 and 54 and 108. I don't want to use 108 because that's twice 54. So let's pick 118. Okay. So let's see what we can do here. Can we divide all of these by 3? The answer is no. We can't divide by 2 because one's odd. So can we divide them all by 3? Or can we, so what we're trying to do is find if there's any number we can divide them all by. And in this case, I can divide this one by 3 and this one by 3, but not this one by 3. Because 1 plus 1 plus 8 is 10. I can't divide them by 3. So 5, I can't divide them by 5. 7, can I divide them by 7? I don't think so. Okay, so I'm going to start with other numbers. So I can divide both of these by 2. So I divide by 2. This one I can't divide by 2, so I bring it down. 54 divided by 2 is 27. And 118 divided by 2 is 59. Next, can I divide any of these by 2 again? No, because they're all odd. So then I'll try 3. Can I divide any 2 by 3? This I can divide by 3, and this I can divide by 3, but this one I can't. So what I do is I divide the ones I can divide and bring the one down that I can't divide. So 21 divided by 3 is 7, 27 divided by 3 is 9, and 59, I just bring it down because I can't divide that by 3. Now I look at it, well, this is already a prime number, so I can't go any further unless I could divide this by 7, which I can't. So can I divide at least 2 out of the 3? Well, I couldn't divide this one by 3. It turns out 59 is a prime number, so we can't go any further. You can't divide these by 3, so I can't, so I'm finished. So the least common multiple of this case is 2 times 3 times 7 times 9 times 59. So it's a really big number. 2 times 3 times 7 times 9 times, oops, got one of the numbers wrong there. 7 times 9 times 59. It's 22,302. Obviously, you wouldn't want to list all the multiples of these to get to that point. It would take forever, but it didn't take very long at all by using this technique. And we could check it. Let's do it the other way. So if we were to do the factorizations of each one of these, prime factorizations, so this one has a number of terms, but this one only has 2 terms, 2 and 59. So those are the prime factorizations of the 3 numbers. So the least common multiple, you list, well, I've actually got to do the prime factorizations here. I didn't do that. So 21 is equal to 3 times 7. 54 is equal to 2 times 3 cubed. And 118 is equal to 2 times 59. So I list all the numbers that are part of any of the factorizations. So I have 2 from here. I have 3 from there. I have 7 from there, and I have 59. And then I go through and I find the highest exponents. Well, this is the only one that has an exponent besides 1, so I cube that. And if I multiply that out, I should get 22,302 if I did it right. 2 times 3 to the 3rd power times 7 times 59 is 22,302. So anyway, I'll let you guys do some homework problems. Yeah, there's one more. I'm going to go ahead and assign these right now. So these will be due, I guess, Wednesday after Thanksgiving. Let me get Miranda her test. No. Yeah, my wife texted me and she says she's going to take a personal day Tuesday so we can go up. We're going to babysit Xander on yeah. Oh, that's right. Yeah, you're here. Yeah, so we're going to babysit on Wednesday. Oh, when am I going, or when am I? Are we talking? Oh, baby, next Wednesday. So the Wednesday before Thanksgiving. Heather's work. Who's that? Oh, yeah, Tuesday. They get out Tuesday, so she's going to take off Tuesday. She's taking a day off so we can drive up instead of driving up later that day. Oh, there you go, just in time. Yeah, what was it Heather said? He was a nurse. Xander was at nursery school or daycare, and I think somebody said, "Hey, Xander, come over here." And he turns around and he goes, "I'm not Xander." I'm like, "Who are you?" Well, he's actually Kevin Alexander, and so they said, "Oh, are you Kevin?" And he goes, "Yes, I'm Kevin." I don't know why. So I don't know if he's decided he's going to be called Kevin or what. Just to confuse everybody. Okay, before we finish here, so I just want to cover this last little bit. There's one last thing you do. What you do is you take the two numbers to get the lowest common multiple. You take the two numbers and you divide by the greatest common factor. So if you already have the greatest common factor, you can find the least common multiple easily. So why don't actually, well, so let's just do this one. We'll find the greatest common factor. Well, or you could solve for greatest common factor and do it the other way. So the greatest common factor is the two numbers multiplied together divided by the least common multiple. So let's actually. So I'm going to do the greatest common factor quickly so that we can get an answer. So here's the two numbers. Actually, let's do it using the second method. So you got 166 and 415, and so you can't divide them by 2 because they're not both even. You can't divide them by 3. You can't divide them by 5. What the heck can you divide them by? 166 divided by, well, maybe this method is not the best way because it's hard to find. It's got a big, so I'm going to do it the other way. do them separately because I can do these separately. So we divide by 2 and we get 83. I think that's a prime number, so we're stopped there. And you can divide this one by 5. So 415 divided by 5 is 83. Okay. So the greatest common factor, so see the prime factorization of these two numbers is equal to 2 times 83, and 415 is equal to 5 times 83. That should be 83. So 415 divided by 5 is 83. So the greatest common factor, you just take the ones that are common to both of them. So for greatest common factor, you choose the one that's in both of them, which is 83. And it's raised to the first power. So what they're saying is the least common multiple is going to be equal to 166 times 415 divided by 83. So 166 times 415 divided by 83 is 830. And you can see if you take 830 divided by 166, you get 5. And if you take 415 divided by 166, not by one, wait a second, no. You take 830 divided by 415, you get 2. So you see that this 830 is the second multiple of this, and it's the fifth multiple of that. And so it's just a way of getting the other term. If you've got one, you can get the other easily. You don't have to go through the long procedure for both of them. So I'm going to do one more here quickly. I think we already did this, right? So this way, I'm going to do it this way. So you divide by 2, you get 55 and 200. And you can divide by 5, and you get 11 and 40. So for the greatest common factor, you go until you can't divide by a common factor, which I can't at this point. And so the greatest common factor is equal to 10, multiplying these two numbers. So the least common multiple is going to be equal to 110 times 400 divided by 10. So you take 110 times 400 divided by 10, and it turns out the least common multiple of those two numbers is 4,400. And again, you can check that out by taking 4,400 and dividing by 110, and you'll get 40. So that's the 40th multiple. And if you take 4,400 divided by 40, you get, oops, you get 110. Okay, I guess that makes sense. So this is the, am I doing the right thing here or not? Oh, by 400. That's what it should be doing here. So you divide by 400. So you take the least common multiple and divide by each one of these separately, and you get which multiple it is. So this is the 11th multiple, and this is the 40th multiple. And so it works out. So anyway, that's the last thing that you can do. Knowing one, you can always find the other. Okay, so we're done. And yes, it is the right time to stop. So we'll see you after Thanksgiving.